Hello friends, this video on Oscillations Part 9 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till Part 8 before going ahead with Part 9. So till now we covered the very basics of simple pendulum the basics of simple harmonic motion, where we just studied what defines the displacement, what is amplitude, phase constant and angular frequency. So based on whatever we studied so far, let us look at a few problems. So this problem says that you are given an equation which defines the motion of an object. Now looking at this equation, you have to say whether the motion is or whether this function represents a simple harmonic motion or a periodic motion but not simple harmonic, or a non-periodic motion. So how do we say that whether the motion is a simple harmonic motion or not? Now let us say what is the equation that is given. It is sine omega t minus cos omega t. And the question also says that if it is a simple harmonic motion, then calculate the period. Now let us see. Now in order to find whether a motion, now let us see in what other form we can write this particular function. So here we have sine omega t minus cos omega t, right? Now if you look at it, we can write it in this form. That is, you are multiplying and dividing by root 2. Similarly, to this term also, you multiply and divide by root 2. Why did I do this? That's because I want to write it in the form of sine omega t. What is the equation for simple harmonic motion? The function that represents simple harmonic motion should be of this form, a sine omega t. So I just want to check if by any way I am able to write this function in this form. So in order to do that, I have multiplied and divided by root 2, so that, because root 2 is the value for which I have both sine theta and cos theta, where theta will be same, because for sine 45 as well as cos 45. So how do we write this? This we can write as root 2. We take as common. This can be written as 1 by root 2 sine omega t minus 1 by root 2 cos omega t. So 1 by root 2, what is 1 by root 2? 1 by root 2 can be written as sine pi by 4 as well as cos pi by 4. Both of them have the same values. That is why I multiplied and divided by root 2, because this is a value for which both sine and cos thetas will be same. So this we can write it as 1 by root 2. This is cos pi by 4 sine omega t minus sine pi by 4 cos omega t. So what is this? This is nothing but sine A cos B minus cos A sine B. And what is that? That is nothing but sine A minus B. So we can write it as sine omega t minus pi by 4. Now this equation is of the form A sine omega t plus phi, where A is equal to root 2 and phi is equal to minus pi by 4. So we can see that this equation can be written in the form of simple harmonic motion equation. So this equation represents a simple harmonic motion. So we say that the motion is simple harmonic. Now we have to calculate the period. If you see, it is a sine function of omega t plus phi. Now for such a sine function, what is the time period? Time period capital T is given by 2 pi by omega. We have already derived it in one of our previous slides. So if you have any function in this form, then the time period is equal to 2 pi by omega. So here also the time period will be the same. Now let us look at another similar problem where you again have a function, and looking at that function you will have to say whether it is a simple harmonic motion or not. Now let us try to do this. This 3 cos, now this can be written as cos of minus 2 omega t minus pi by 4. Right? Now we know that cos of minus theta is equal to cos theta. Now using this fact, we can say that this is equal to 3 cos 2 omega t minus pi by 4. Now using the equation for simple harmonic motion, what is the general equation for simple harmonic motion? That is equal to a cos omega t plus phi. So here we have omega, but here in this case we have 2 omega t. So what we can say, using the same logic which we applied before, we can say that this function is a simple harmonic motion because it is of this pattern. So the motion is SHM. So this is also simple harmonic motion. Now in order to calculate the time period, we can say that if we look at this particular function, we can say that it will repeat its value after 2 pi. That means cos theta is equal to cos theta plus 2 pi. So we can say that in this case, this 2 omega t is equal to 2 pi. Because normally in this general equation, we say that omega t is equal to 2 pi. Omega t is equal to 2 pi. So in this equation, it becomes 2 omega t is equal to 2 pi. So we can say that the time period is equal to pi by omega. So what is the concept behind how we get this equation? It is nothing but cos theta is equal to cos theta plus 2 pi. So we say that the initial angle or the initial phase was pi by 4. So when pi by 4 increases by 2 pi, then the value becomes same. So this increase, that is this 2 omega t, should be equal to 2 pi for the motion to repeat its patterns over and again. So this 2 omega t was equal to 2 pi, and therefore we get the time period as pi. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.